Hey, and welcome back to part 2 of our Squid Game tutorial. We've been making the red light, green light game from episode 1 of the iconic Netflix series Squid Game.
You will be playing red light, green light.
Green light. Red light.
In part 1, we got a character moving across the screen in a horizontally scrolling world, but most of the rest of the game elements haven't been implemented yet. We have some lovely art of the creepy doll from Squid Game, and in this episode we're going to be bringing it to life and adding a whole bunch of other elements. By the end of today's episode, you're going to have basically a fully functional single-player game. And then next episode, when we wrap up, I'll teach you how to add AI to this little challenge, so that instead of just you competing against the doll, we'll have some other opponents to compete against as well. So lots coming right up. Let's get right to it. So in front of me, I have the part 1 catch-up file, which is basically all the code that we completed in part 1 of this tutorial. If you get stuck anywhere all along the line while following part 1 and you just have an issue that you can't solve, just load up this file and have all the coding ready for you. As I like to tell my students, it's not critical that you get every single step along the way here. If you forget something, rather than pulling your hair out trying to fix a minor problem, it's more important that you just keep following along with the tutorial and stay caught up with us so that you can build the next part. So don't get too worried about that. Just load this file up and you can start coding from here. If you started last week, you should be good to go from here using the file that you created last week. There's a few variables that I think might have to be added, or messages that you might see me using here that don't necessarily exist in the startup file, but don't worry about that at all. Just you guys, I'm sure, know how to add those yourself. So I'm zoomed in on the play area here right now, and as you can see, we kind of got it going here. We got our character who moves around, and we've got an animation happening where he tilts and moves. He's basically stuck. His X position is fixed on the screen right now, and that's not going to change until we add a little bit more code. And what's going to happen is he's going to run about 100 units across the screen here, and then he's actually going to start physically moving across the screen until he crosses the finish line. Most of what we're going to be working on today is going to be the timing of the game and getting everything set up so that all the sound effects and music and stuff all kind of interact with each other in the proper timing. We're going to be using message commands and some custom blocks and things just to orchestrate kind of a symphony of different actions between a whole bunch of different sprites here. So we're going to be starting with this it head. You can see that the creepy doll from Squid Game is here. I've got him cut into two pieces here. So I've got the head, and then I've got the body down below here. The body has multiple costumes. Rather than animating the arms differently, I just created a bunch of costumes to show the arm kind of stretching out and eventually touching the tree that's in the background here. And that's going to be spinning around simultaneously with the head as well, and basically that's all going to be timed properly so that we have a nice little introductory sequence that uses some of the sound effects from the original show to add a creepy sense of realism to our project here. Alright, so I think we're ready to start coding here. So I am inside the it head. This doll doesn't have a name inside the Squid Game show. They just call it it, like you're it in tag, and so that I've kept that naming convention here. So this is called it head. And right now you can see we broadcast a go message here right underneath the green flag. So in this game, nothing is going to happen when you click the green flag, or there will be no actual code underneath the green flag. The reason for that is I've coded it in such a way that when you click, after you've died in the game, you'll be able to restart the game without clicking the green flag again. So any code that I put underneath the green flag wouldn't run in the case of us restarting the game that way. So I've had to code this in such a way that there's really nothing but a single broadcast under the green flag, and then when we click, that same broadcast is going to happen as well. And that way, no matter how we try to start the game, we'll still have the same experience. Okay, so we're 2 blocks into my tutorial and I've already messed something up, guys. The broadcast here is actually supposed to be not go, but intro. So intro is the part where the creepy doll's going to read the rules out and some other introductory music and stuff is going to play. The go is actually the part where players start moving, ready, set, go, in that fashion. So we're going to be using that in a minute. Let's start off with the broadcast intro. And so when I receive that intro, let's grab this block of code down here. We're going to set just a couple of variables. We've got one variable here called a turn, which is just saying which round of the game that we're in. So when the doll says green light, we start turn 1, and then she'll say red light, and then she'll say green light again, and it'll be turn 2. The turn is only really important because on the first turn, we're going to be eliminating a bunch of players. Just if you had seen the show, you'd know that at the beginning everyone's kind of confused by the game rules, and when things take a deadly turn, people start to panic and a whole bunch of players end up getting eliminated all at once. And so to simulate that, we're going to have a situation where in the first turn lots and lots of players are eliminated, and then later on that number trickles off a little bit. So we'll be programming then the AI, which won't come up till next week probably. All right, we're going to set a timer for 60 seconds here, and that's the amount of time you're going to have to cross the finish line here. And if that timer runs to 0, then the game will be over, regardless of where you are on the screen. Great. All right, a few other things we want to set up here. So we're setting the volume to 100%. We're going to be playing around with the volume as the game continues here, so we want to make sure that every time we restart, our volume is back at 100%. We're going to switch the costume to doll head. Later on, we're going to be using this red eyes costume, which is going to signal that players are being eliminated, and we just need to make sure that it goes back here every time we start the game again. We're going to make sure it's at the front layer so that it's in front of its body, of course, on top of it. And we're going to set a starting position for it. It's just 158x and y of 0. And we're going to point to the right here, the default, which is a little bit odd because we're actually pointing to the left. So in an earlier version of the game, I had stuff going to the left, but then I flipped it around. So normally, a good rule of thumb is you should always be creating your characters so they're facing to the right here. But I just didn't want to change my code around here, so all my characters are, this particular character is facing off to the left. No big deal, though. We're going to tell him that when I point in direction 90, she's going to be facing to in her default direction, which is the left. So sorry about that confusion here. All right. Now, next up here, we're going to broadcast something that says theme here. And that's just going to get the introductory Squid Game music going. Now, I could have just played the theme file right here, but I've put the theme over in this other sprite called Thumbnail. And I didn't want to put the same piece of music in 2 different sprites just to keep the file size a little bit smaller. So I've just done a broadcast to get that theme music going. And let's jump over to that sprite right now. So I'm in the thumbnail sprite where I've got the introductory thumbnail as well as a win and lose condition set up here. And the only code we're going to need right now is just when I receive theme, we're going to make sure the volume's at 100% again, and we're going to start this little bit of theme music from Squid Game, which you guys, I'm sure, will recognize. I really love that creepy little choir tune. And that's all we're going to need here. Then back to our head again. We're going to let that music run for 2 seconds. And then we're going to start reading the rules to the game. And so the rules are contained inside the sprite here, the little sound file that explains what's going on here.
Here is the first game. You will be playing red light.
And even has the sound effect of the doll spinning around. So we're going to take advantage of that sound effect and have our doll actually start spinning around after 1.5 seconds. So that's the way that's going to work. Now let's go ahead and add the spin there. So it's we want it spinning quite slow, so we're going to do a repeat of 180 times and turn just 1 degree clockwise every time we go. Okay, so we're ready to test this out now and see how well I've synchronized my sounds up here. Let's give this a try. Click the green flag.
Here is the first game. You will be playing red light, green light. You are allowed to move forward when it shouts out green light. Stop when it shouts red light. If your movement is detected afterwards, you will be eliminated.
All right, so that worked beautifully. You can see how it really sounds like the character's head is spinning around with all these gyros and servos or whatever kind of technology going on behind the scenes here. When you time things properly, it really adds to the realism of the game, as you can see here. Okay. Now all of that chatting takes about 10 seconds or so. And so we're going to wait for that to end, then we're going to broadcast that go message that's going to get the actual gameplay going. Now, in a little bit later, we're going to program kind of a cheat here that gets us out of this whole intro. I think the first time you listen to it, it's going to be kind of cool and creepy, but you're going to want to skip past it at some point. So we're going to do a little trick here where when you press the space bar, you skip right past that and broadcast the go right away. While we're discussing the skip button, I thought I might as well just quickly code it. It's not too much code here, so let's just jump right over to that sprite that's called skip button right here. You don't really see anything going on here because the sprite is colored white. You can see when I hover over it with a paintbrush, you can see what it actually says, space to skip intro. Just a nice little interface element that's going to be a little more user-friendly. You don't want your players to sit around bored playing your game, or that's going to decrease their likelihood to want to actually play your game. So these kind of little shortcuts are much appreciated. Also, like a mute button is really useful as well if you've got a game with a lot of background music or something that's going to be annoying to players. In this case, the sound is very important, so I don't think a mute would be appropriate because the sounds are actually going to be part of the way that you know whether you should stop playing or stop moving or not before the doll turns around. Okay, so let's go ahead and code this. So it's fairly straightforward. When I receive intro, so when that first message comes on saying the intro started, we're just going to set a variable called skipped to 0, and that's just going to detect whether we have actually hit that skip button or not. So later on, when we press the space key, that's going to shift to 1, and that's just going to keep track of the fact that we actually did click that button once. Now, this is invisible by default, so we're going to make sure it's showing here, but we're going to set its ghost to 100. So it's going to be invisible for 1 second, and then it's slowly going to appear using this change ghost effect. And that's going to make it basically slowly fade onto the screen. Now we've got a when space key pressed event here, and here's where that skipped variable comes in. So if skipped equals 0, so the first time we press the space key, that skipped will be 0. And then at that point, we're going to stop all the other action. Even if we're in the middle of turning around here and all the sound effects are playing, we're going to stop those sound effects. And we're just going to jump right to the go here at the right away. And the doll head later on is going to spin right into that 90-degree position as soon as that go happens as well, and then we'll be ready to start playing the game. So this basically interrupts all the action no matter what's happening and gets everything set for that go command. Then we're going to immediately set that skipped to 1 so that the next time we press the space key by accident, we're not going to accidentally reset the game again. Once we've pressed the button, of course, we don't need it anymore, so we're going to hide that prompt to skip the game, and it'll show up again the next time we restart the game with the intro. All right, the last thing we need here is if we do let the timer run out, or the all the events inside the intro run out, and we don't hit the space key, we still need the event to hide. So when I receive that green light message that says the game is running, that comes right after go, and we'll see this in a second. So when I receive a message called green light, we're also going to hide here. So we can test this all out here. Let's max the screen out. And we'll go to the space key, and we can see that that appears at the bottom of the screen. And when I hit the space, it stops. Now my head's still not spun in the right direction. Let's get right to that right now, actually. So let's go back to the head here, And so we can start programming the go event here. So this is what's going to happen when the game starts going. The first thing we're going to do is set a variable called red light to 0. And red light is going to shift to 1 every time that the head spins around and says red light. And that's how some of the other code inside the game is going to know that we can start eliminating players. We're going to stop other scripts in this sprite at this time. Again, if this guy's in the middle of spinning and we've skipped right to the go, we want to jump ahead and finish all those movements up so that everything is ready to actually to be in the position where it would be when the players start running. We're going to stop all our sounds here as well, just in case that those rules are still running. Now we're going to broadcast a message here called track distance, and as soon as we start running, we're going to want to keep track of where our player is on the screen. And there's a sorry, not on the screen, but on the bigger playing board. As we saw yesterday, the playing screen goes far beyond this little piece here. It keeps going and going well past here, so using a scrolling x coordinates here. So we're just using a variable to keep track of how far you've run across this board, and that's going to come in handy later when we get close to the finish line so that we can actually start moving closer to it. We're also going to have a little readout at the bottom here that's telling us how far we've run so far so that we can know how far away the finish line is. All right, so we're going to start tracking our distance, and we'll get to that in just a second here. And we also want to point in direction -90, which, as I said, just finishes that spinning motion in case we don't have time for the animation to actually run through the way that it normally does. Okay, so now you can see that our skip ahead function here is working much better now. So as soon as I hit the space key, everything else stops, and we're basically ready to go with the running. And what happens then, we'll have to code next. Okay, let's pause momentarily on the doll's head and jump to the body. And we want that to be spinning more or less simultaneously with the head the first time around, and then later on the head's going to spin independently. So at the beginning of the game, this body is going to spin once to match the head, and then it's just going to stay in that position for the rest of the game. So let's have a look at that code quickly. So when I get that intro message, we're going to want to start in our default position, which, because of the way that I set this file up, is actually -90, and that'll get her facing to the left, which is where we want her to go. And then we're going to set up her starting position, which is the same as the doll head, which is an X of 158 and a Y of 0. We're going to tell her to go to the back layer, but we don't want her behind this. So we want her behind the head, but we don't want her behind this end zone area that I've set up here. So we're going to move her forward a few layers, 3 layers, and that'll make sure she's in front of the end zone. And there's a couple of other things moving around, so we just want to make sure she's in the right place. And then we want to make sure she's wearing the default costume, which is doll 1. Then we're going to wait 3.5 seconds. Now that's the same amount of time we wait to start movement in the head. In the head we split it into 2 different parts. 1.5 seconds here, and then 2 seconds up here as well. So it still adds up to the same thing, 3.5 seconds. And then we're going to get her into a little loop, the same as the head, where we're spinning around slowly, 1 degree at a time, 180 times. So now the head should be all synchronized properly. Let's have a look at that. Beautiful. So she's spinning around quite nicely now.
You are allowed to
I
move
like it.
forward
Okay.
when it shouts out green light. Stop when it...
Now we still have to implement that space bar that will skip her back into this position right away. So let's go over and grab a when I receive go, just like we did in the doll head. And in there, we're going to stop other scripts in the sprite. That's going to stop this rotation script if we're in the middle of that. And then we're going to just immediately point to the right, and we're going to switch to the end here. Now we still haven't changed the animation around. There's a little bit more to do over, sorry, I think I jumped ahead here in our intro. We still have a little bit to do here, and that is we're going to be shifting through these costumes. So each time that we go around this loop, we're going to change next costume, and we're going to go through all the various costume iterations. So that will get her moving, extending her arm out and touching the tree. So I think we're good to go here. So let's test that one more time. So now click the green flag. And you see that she spins around. And then when she stops spinning, she extends her arm out in time, nice time with the background sounds. And so that's working beautifully. Now let's just try that space key again, just to confirm that we're circumventing that normal process. So as she starts spinning, I'll press the space key, and there we go. And we're jumping right ahead to the go part of the game. Okay, there's one more element I'd like to do that has to do with the introduction to the game, and that is this sprite called Halo. Right over here, you'll see it. So in our playtesting for this game, we found it was pretty hard to figure out which character was yours. When we program the AI next week, you're going to see there's going to be about 30 of these AI arrayed around the screen here. And while your character's kind of in the middle of them, it's not obvious which one is yours, even though I have changed the shade of green a little bit to make it a bit more obvious. So what we decided to do in the early playtesting was to add this little yellow halo around your character just in the first couple of seconds, just to highlight who your character was. But our playtesters, thanks to funny animator Jim, by the way, who playtested this for me, he suggested that we needed a little bit more of a visual accentuation to make it obvious which player was yours. So just today I've gone ahead and added these white rings that kind of grow and expand across the screen and then disappear again. And we're just going to run a little quick animation to flip through these as we fade this in and out, and that's going to make it a little more obvious that this is your character here. The code's not too tricky. Let me show it to you right now. So when I get that intro, we're going to hide this at the beginning. We want to wait a second for the music to start playing and for you to get settled into the game before we show you which player's yours. You're not going to be able to do anything for the first second or for the first few seconds of the game anyway, so we're just going to delay this a little bit. So we do want to send this halo over to our player character. It's perfectly centered, so it should pop up right in the middle of him. We're going to tell it to go backwards one layer so that it's behind our player character. We want to make sure it's wearing the right costume, so we're going to put costume 1 on it. Then, while it's sitting there invisible, we're going to wait 1 second, and then we're going to very quickly show it, but it's going to be invisible still because the ghost effect will be set to 100. So we're still invisible here, and then we're going to slowly fade it in. We're going to repeat 20 times, changing our ghost effect by -5. So that'll take our ghost effect from 100, which is completely invisible, over to 0. 20 times -5 is -100, so that'll bring us back to 0, which will be completely visible. And then I'm going to run through these 7 animations, and we're going to do it 3 times. So I'm going to repeat 21 times next costume. We'll put a little bit of a delay in between, 0.1 seconds, just to leave some time so that it doesn't burn out too quickly here. And then we're just going to fade it away, so we'll change the ghost effect by 5. Little bit more code here, just where again we want to circumvent things in case we press that space key. So when I receive that go signal, like when the space key happens or when the round starts, I'm just going to stop this if we're in the middle of it, and then I'll go ahead and hide it. Let's have a look at what that looks like. Yeah, and that's pretty obvious. I don't think there should be any doubt now over which is your player. And let's try that again. This time we'll again do the shortcut here to get rid of that. And again, that all disappears and we're ready to go again. Excellent. Okay, we're going to keep setting the stage here. This little tableau wouldn't be complete without a couple of the creepy Squid Game guards who are going to be supervising the action here. And just like in the TV show, they have little circle patterns on their faces. So this is a top-down view. It was designed by my wife Lynn, who's a bit of an artist, as I've mentioned before, and I just traced over her drawing and placed that into Scratch that way. So it's looking pretty good. We just need 2 of them, and that's the way it was in the show. So we just need to position them properly. They're not going to move or do anything interesting, and they don't have any costumes. We're just going to position them on the screen here. So just a bit of code to do that. So when I receive the intro right at the beginning of the game, we're going to set them in the first guy in his initial position up above the creepy doll. And we're going to point him off to the left the way he should be. Then we're going to make a clone of ourselves. And we're going to move that clone down exactly 200 pixels so that it's on the opposite side of the doll, who's at a Y of 0. So because we're starting at 100, we're 100 away from the center of the doll, and then 200 lower will be again 100 away from the bottom part of the doll. So that's all there is to that. One other little bit of code we're going to add here, and that is this little shadow sprite. Let me show that to you. It's just a little tiny gradient here, and I've added this. Once we add a bit of transparency to it, it'll look better, but we're going to position this right along the edge of the finish line here, and what that's going to do is create a bit of a transition between the moving floor and the stage, which is going to be still. So we're creating the impression that this stage is fixed into position here while the floor is moving around underneath it, and that shadow effect really helps out a lot. So let's go ahead and code that. We can have that happen right at the beginning, and it only really has to happen once. So we're going to go, when green flag clicked, we're going to send it to its starting position, which is 64x and a Y of 0. And we just want to give it a ghost effect here. So we're going to go onto our looks commands here and go set ghost effect to 50. There we go. And so that'll make it a little transparent, and it's invisible in the template version of the game. So I'm just going to make it show here. We're going to click the green flag, and you'll see what that looks like. So there you see, as we're moving along here,
You'll be playing red light, green light.
you can see that as we're moving along the floor here, you can kind of see this shadow, and it kind of makes it look like the doll and the stage area are all kind of superimposed on top of this floor here, like they're kind of above everything. And that to me helps to kind of sell this idea that that the stage is standing still while the floor is moving. Okay, so far so good. Okay, we're back inside the doll sprite, and this is where a lot of the action of the game is going to be happening. Just like in the TV show, the doll is going to be controlling the action of the game here, telling the players when they can run and when they have to stand still, and deciding who's going to get eliminated or not. So all of that code is going to be embedded in here, and inside this go thing, we're just going to get a loop where we're going around and around and around, doing one round, and then pausing, and then doing the next round, etc. Now there's one little correction I want to make to some code that I messed up here. In an earlier version of the game, I had this track distance where we're controlling or figuring out how far we've gone along the screen, and that is no longer happening now. We're going to get rid of that right now. So please just delete that block. We're not going to need that event anymore at this point. So I'm going to reattach this point in direction. And let's get a forever loop, and we can start putting stuff inside here now. So we're going to change our turn by 1. Our turn number was 0 at the beginning. So as soon as we get into this loop, we're going to start to turn 1. And inside there, we're going to do a broadcast, green light, and wait. And the way that that works is we don't use broadcast and wait very often, or at least I don't. So generally speaking, when you send a broadcast out, you're sending a message to another sprite or to another part of this sprite to start a new branch of code there. And usually the code, once you send that broadcast out, the code just continues on and reads the next line. And so it's really useful for having things happen simultaneously. But in this game, this is all about turn taking. And so we're going to use this broadcast to make sure that the action doesn't proceed until the other line of, until the action that's happening inside this green light event is completely ended, and then only then will the code return back to this spot and then continue running along here. So this is a good way to control the action in turn-taking games like this one, and I thought I'd demonstrate how that works today. So we're going to broadcast that green light message. And when we get that message, so I'm going to just finish up this code later. Let's show you what happens when the green light, when the green light message is received. First of all, in previous turns, if we'd eliminated a player, our doll eyes might be red again. So we're going to have to switch that back to the default doll head, just in case those eyes are red, to turn it back to a normal thing, to a normal costume. Okay, so instead of doing a whole bunch of timing here to figure out how long these audio clips are going to be, I'm going to use play sound until done. And what that's going to do, of course, is pause all the action until all of these audio clips are finished playing. So first thing we have here is the creepy doll saying green light.
Green light.
And I'll plunk that down there. Next, she's going to sing her creepy song. Now, you wouldn't have heard this if you were listening to the dubbed version of Squid Game, but she sings this Korean song. She never actually says green light in the show, but I thought it would be useful to give the English instruction here and then play the Korean song. So this is a bit of a hybrid of the dubbed version and the subtitled version. If you are watching this show, by the way, I would strongly suggest you watch the subtitled version rather than the dubbed version. I know it's a lot of reading, but the dialogue is quite a bit different, and you miss some great performances from the actors when the voices are dubbed over. Anyway, so this is the creepy song that shows up in the subtitled version. Anyway, and when she's done playing that sound, we're going to have her say red light.
Red light.
And then she's going to spin her head around. Now this part has to happen simultaneously with the movement, so instead of doing it until done here, we are going to just have this quickly play that sound, and while it's playing this sound, it'll continue to do the head spinny part. So here's the fast head spin sound. There we go. Let's plunk that in there. And then we need to actually rotate her head around. We want it to happen very, very quickly. So I'm going to go repeat 4 times and turn 45 degrees. That's about as fast as I can spin that head around without making the animation look a little bit ridiculous. So let me show you what that looks like. Actually, I'm going to attach this to a space key so that I can max out the screen here and show you that head spin here. So when I click the green flag, go space once, and then you can see the head spinning around again. So that's what that looks like. All right. So we're going to get rid of that, and we'll plunk this repeat loop back in here. One other little detail I want to add inside this green light event, and to understand this, you need to know a little bit of the backstory of Squid Game, which I'm hoping some of you kids probably haven't seen, the younger ones here. Anyway, so after the first round of red light, green light, things get a little scary for the players, and they realize that things aren't exactly as they seem. And so in that first round, a whole bunch of players panic and start running around like crazy. And to simulate that, I've downloaded a sound effect here called Crowd Panic. Let me play that for you. And we're going to run that sound only during the first round. So you remember that we have a variable here called turn, which tells us what turn we're in. And since we're in turn 1 right now, we're just going to wait 1 second and then start playing that sound. And that will only happen the first time, and then on subsequent plays, there's just going to be silence there. Okay, we're almost ready to test this. I need to go back up to the main go sequence here, though. So after the green light is over and then the doll calls out red light, the game's going to reset itself and we'll be ready for our next round. So to do that, we need to first wait. We're going to make the game a little bit more difficult, we're having the actions of the doll be a little unpredictable. So we're going to wait a random amount of time between 1 and 4 seconds. I just took a wait block and added a random number in there. Then we're going to reset the doll's head again. So it's going to spin around, not as quickly as it did before, and then it's going to, the game's going to be ready to play the next round again. So I'm going to broadcast this reset message. We're going to again branch off to a different piece of code here. And here's the reset event. So you can see how we're using wait commands here, the broadcast and wait commands here to kind of branch the program off. We're going from go and then broadcasting the green light event, letting that run through, and then coming back here again when it's done, and then again we're going to broadcast and do something else. Now we could have put this all inside one loop, but I really like the idea of keeping this tidy so that each section of the code handles a different function, and you can see how much easier it is to understand what's happening here. So let's do the reset part here. We've got a different sound effect for the doll head spinning a little slower. There we go. And then we're going to set our red light variable to 0 to tell the game that we're no longer catching people anymore, and that way you'll be able to start running without any consequences. Then that head's going to spin back again, so we're going to do, as I said, a little bit slower. I timed this to go with the sound effect, so we're going to spin 9 degrees 20 times, so for a total of 180, but just a little bit slower than before. And that's going to reset, and then it'll come all the way back around this loop again, change the turn, broadcast another green light, and start again. So let's just let that cycle run through a couple of times, and you'll get an impression of what's going on here. Okay, so let's test that out and see how this timing works now.
Here is the first game. You will be playing red light, green light.
We'll just skip through here.
Green light. 무궁화 꽃이 피었습니다. Red light.
And that first time the crowd panics.
Green light. 무궁화 꽃이
Beautiful. Okay, so that crowd screaming sound seems like it's going a little bit too long at first glance here, but what's not in the game yet is the elimination component, where our players are going to be eliminated one at a time. They're going to kind of run around the screen a little bit, and then this red elimination banner is going to appear across them, and then their sprite is going to change to this X banner here. Not too gory, and anyway, so that's all going to happen later on when we program our AI, which is coming up next week. So that whole process is in that first round, when we're going to catch quite a few of these people, is going to probably take 10 seconds or so. So that screaming will be long over by the time that elimination round is over, and then it'll be silent when you go back into the game again. Okay, so before we get too much further, I'd like to clean up a few things inside the player sprite here. So you might have recalled that when we put these green flags down in part 1, I suggested that they weren't going to stay there, because at some point we're going to get events that we're going to cover that. And the reason being that if I click the green flag and initialize these variables, for example, the next time I restart the game, if I don't click the green flag, if I just click on the screen, which we're going to set up a little bit later, then we're not going to be able to restart the game properly, because all these variables aren't going to initialize. So we're going to get rid of this green flag, and we're going to replace it with a when I receive, and that's going to be the intro, right? So then that will restart the game for us again and get us back to the beginning. There's also another green flag a little further down here. We really want to remove all the green flags from the player. There won't be a single one left once we're done here. So this is a section of the code here that controls the footsteps. And that part is not going to run until we get the go command. So let's replace that with a when I receive go. Of course, we don't need footsteps till we start moving. And here's another green flag. So this green flag is the one that controls our forward movement. And this one again is going to be set up to work under when I receive go. And there's an important side effect of that, which is that we're not going to be able to move at the beginning during the part when the introduction and the rule setting is going to begin. So that's going to stop you from cheating. Your character's going to be frozen in place until the doll shouts green light, and then this will be unlocked, and then from there we'll be into a forever loop where we can just keep moving as much as we want to. Of course, we don't want to move during the red light because you know what happens. And I think that's all the green flags in there. Excellent. Okay, so we're going to move along now and do a little bit of work on the thumbnail. So let's get back to this thumbnail. Remember, the thumbnail serves a bunch of purposes. Number one, it is, as the name suggests, it's a thumbnail, so it's going to be the first thing you see when you find my game on the Scratch server. A nice little introduction to the game, but it's also going to function as a you win screen, and we coded that last week, and also with a game over screen as well. Now, we want to code all this stuff in such a way that it's always at the front, which of course will obscure the game, and this is a technique that's used a lot with thumbnails in Scratch, and we're going to use it for all of this stuff today. We're just going to constantly be moving this sprite to the front inside a forever loop, but we're going to ghost it at 100% so that it's not visible until we actually unghost it, which will allow it to fade away or fade in as we need it. And the great advantage of that as well is if we hit the stop button, this is going to suddenly appear, and that's exactly what we want to have happen. So that will make it so that no matter what happens, when you finish playing the game, you'll see this beautiful intro screen again, which is kind of the way a nice professional looking game looks. Okay, so we did some of the coding here yesterday, or sorry, in part one, we coded the you win section here. And you can see how that works here, but we did not enable the code to bring it to the front constantly, so that's what we're going to do right now. Let me just jump over to there where I have it partially constructed already. So when the green flag is clicked, we're going to show this screen, because of course we do want it visible at the beginning of the game. We're going to want our thumbnail visible. Now we've got a couple of variables, and I didn't show you this variable last time. I've created it since the beginning of this, after part one. I did some more playing around with the game, and I realized there needed to be a time constraint like there is in the ordinary show. So as soon as we get going, a 60-second timer is going to go down, and that's going to start to add to the pressure to finish this, because if you don't finish before the timer runs out, then you're going to lose the game, regardless of whether you've been caught by the doll as well. So we've got two different variables. One of them is called distance and the other one's called time. We need to hide both of those on the screen at the beginning so they don't cover up our screen, or so they don't obscure stuff inside our thumbnail. We're going to make sure that we're looking at that cover image because we have two other images to choose from. We're going to make sure we're in the center, so we're just going to go to XX of 0, 0. And when I click the green flag, it's going to slowly fade away. So we're just going to increase the ghost factor by 50 times until that gets down to 100. Okay, so when the time comes to actually play the game, when that intro is received, which should be right after this finishes fading out, we're going to show those variables again. And that is pretty much it for the intro. So let me show you what that looks like. There you go, and that gets us into the intro of the game. And when I stop, you can see that it appears again. Now, that time variable is in the wrong place, and I'm not quite sure how that happened, but let's adjust it now. I'm going to right-click on it to turn it from time to a large readout. And that's going to look the same as the other one now. I'm just going to plunk it right down here beside it. It might take some fiddling around to get it in the right place. There we go. Now there is a little readout. I'm going to hide the thumbnail again just so we can get back to the proper code here. There is a little readout here, and ironically it is called readout. And where did that go? Oh, here it is. It's called distance. All right, and I'm going to show this. There's no code on this. It's just a label that's going on top of our variables here, just so we know what the variables are, since we're not using the proper name tags on them. I want to adjust that a little bit to center it. Now, this sprite does exist in the starter file that I gave you, but the time label is not there. So if you are working off the original starter file, just go into the costumes here, and after distance, just type, I think, about 4 spaces, and then type time right after that, and then you're just adding that to the existing text there. And you can space that however you like to make it look pretty, but that's all that there is to it. There's no code necessary there, though if you do want to make sure it's placed properly, we can always just go grab a green flag, and then we can position it. As always with Scratch, if your game is stopped, these go-to commands will automatically update to wherever your sprite currently is, so you don't need to figure out what its current XY coordinates are. They're 137 minus 135, which we can confirm down here in our other information panel here. You can see that we are in fact on the right location here. Okay, so there's one other item we want to attend to right now while we're looking at the thumbnail sprite, and that is stacking order. You might recall stacking order means which item is in the front and which one is behind when 2 items are occupying the same space. So in most cases, this thumbnail is going to be at the front. It might be invisible a lot of the time, but we want it to be ready to appear whenever we hit that stop button or whenever we win or lose the game. The one exception, though, is when we win, there's one other sprite that we're going to want to bring to the front of that, and that is this item here called Your Rank. Let me show it to you here. So we've got a sprite here that says Your Rank first place. That's the first costume, and the second costume, not surprisingly, is second place. And then we've got a series of costumes here depending on what place you've ranked in the race. So in addition to just winning, we also want to track which of the how many AIs managed to get through cross the finish line before you did, and that's what that's all about. So that is going to have to go to the front of the You Win screen. So we need to set up a circumstance here where the thumbnail is always at the front unless we win, in which case we want to bring it back 1 layer. Okay, let's go ahead and code that. So we're going to start with a when I receive intro. We want to start this forever loop off right at the beginning of the game. We don't want to put under the green flag again for the same reasons that we did for the rest of the stuff. We want to be able to restart this when we click on the screen to restart the game. So we're going to tell it to go to the front here, and that's fairly straightforward. So we're just in an infinite loop here, but we're going to want to interrupt this loop when we cross the finish line. There's going to be an event in there that handles that, and that's down here. So the event is called when I show rank, when I receive show rank, and that's just going to be the thing that flashes at the very end of the game. We're not going to look at it this week because our AIs aren't running in the race yet, and we'll be looking at that in the next week. But when I receive show rank, we're going to want to stop other scripts in the sprite. Now you'll remember you find that sprite right here under Control, Stop All, and we can modify that to say Stop Other Scripts in the sprite. So that will stop this loop from happening. It'll cancel that and we can set up a new loop here. Now I'm going to use a repeat until instead of a forever here because we don't want this loop running forever and then to go back and start running this loop again. It's going to get really confused. It's not going to know whether to go to the front or go to the front and back 1 layer. So inside here we are going to say go backward 1 layer. And we're going to want to repeat this loop basically until the game restarts again. Now, there's a bunch of ways that Scratch could know that we've restarted the game here, but the one I selected is we're going to look at the variable turn, which shows us what turn we're in. That goes back to 0 at the beginning of the game again. So that will be a shorthand way of us knowing that we've restarted the game. So we're going to go repeat until turn equals 0. And so this loop will keep running until the game restarts, and then it'll automatically restart itself. Stop itself, and then this will restart again. And so that will get everything going quite nicely. Now we are switching costumes randomly through this whole process, so we do want to make sure that once we've restarted the game again, we want to be back in that cover image sprite again. So let's go ahead and put that there. And now we're good to go. All right, something else we need to do here is get our game over event set up. We already have the you win factor set up, which we did in week 1, but we also want a when I receive game over, and we'll be attending to when actually ends the game in a little bit. But so when I receive game over, we're going to make sure our volume's up nice and high. We're going to play that theme music again. And we want to hide those 2 variables because we don't want them on the screen while we're looking at the pretty game over sign. We want to switch that costume to the game over screen, just like that. Let's hide those variables as well, just to show you what it's going to look like. And now we can see the click to play again down over on the bottom here. That's actually baked right into the graphic. All right, so when I receive game over, we're going to want this to slowly appear, to fade into the screen. So we're going to take the ghost effect, which is already at 100%, and just slide it down until it gets down to 0, and that will make this appear. All right, the last thing we're going to do with this game over screen is we're going to wait 10 seconds. So basically, if we just walk away from the game at this point and let it sit for a while, it'll eventually revert back to its original red light, green light cover title. And that's just an extra little feature I wanted to add to make it nice and pretty. Okay, one last element inside of this thumbnail sprite, which is, as I said, we can restart the game again by clicking anywhere on the screen after we've died. Now, I won't be able to demo this until we actually get our death set up, which is what we're going to be working on in just a second. But let's just, while we're inside the thumbnail here, let's just get right to it. So when the sprite is clicked, we're just going to fade away. We're going to repeat 10 and change our ghost effect by 10, and that'll make whatever we're looking at invisible. And then we're going to broadcast that intro, which will get our game started again. I can actually click here and get the game started that way. Let's try that. There we go. You see, so that kind of circumvents the green flag, which is kind of nice. It's just an extra little feature, and it's certainly not mandatory. Okay, so that's it for that. Let's go back to our player sprite now. So now we need to start checking to see if we're going to die or not. And the way we're going to know we're going to be dead is if we happen to move during a time when red light has been called. Now, there's a variable called red light, and if that red light variable is equal to 1, then we're going to end up being eliminated. So when I receive go, we're going to start checking forever. So as soon as the game starts, we're going to check forever. And we're going to see if red light is equal to 1. So we're just going to keep going through this loop, waiting for red light to be equal to 1. I'm going to pop another if statement inside this one. I could have done this as an if but I think it's a little easier to do it this way. So we're putting an if inside an if. And I think that actually will make the code run a little faster because it won't have to read this stuff unless red light is equal to 1. All right, so we're basically trying to detect movement. So we're going to check if our y speed is equal to 0, but we don't want to know if our y speed is equal to 0. We want to know if it's not 0. So if we have the slightest bit of movement at all, if our y speed is measuring anything above 0, or if our x speed is measuring anything above 0. So we'll put that inside an or statement, so you can see how that's constructed. If I'm moving in any direction, which means my speed is going to be greater than 0, then, and the reason we did not equal to instead of greater than, though, is because our y speed and x speed can also be negative as well, so remember that. So that's why I use this construction, which doesn't seem logical at first, but I hope you get it now. So we're going to say if our speed is not 0 in either direction, that's what's going to kill us. So at that point, we're going to broadcast it dead, and we're going to stop this script. We don't need to keep checking this anymore. We're just going to keep killing us over and over again, of course. All right, that part is good. So when I receive that dead message, there's a couple of things that's going to happen now. First of all, so now that we've received this message, we can stop all the other scripts as well. That means we're no longer able to move or do anything else because we've been eliminated. So I'm just going to stop other scripts in this sprite. I'm going to broadcast a message called eliminated. I'm going to show you what that does in a second, but let's just finish up here first. So that's going to cause something else to flash on the screen. Then we're going to want to make our character kind of glow here a little bit, just to give an extra visual signal suggesting that he is out of commission. So I'm just going to hide a few elements here so that I don't clog up the screen with stuff. And let me show you that. So we're going to change brightness effect by 3, and you can see what that does. It just makes him glow bright white. And then we're just going to make it go back down again by having him disappear, and then that will be the end of that, and that will be the end of the game. All right, so I just want to show you that. Oh, and then we're going to broadcast a game over. I forgot there's one extra step, and that's going to make that game over screen appear after we're done fading out of the screen. All right, so there's one last thing that we need to code here to make this elimination look really cool. I have this graphic here called eliminated, and what I thought would be really cool is if it just started off invisible and really, really big, and then went shunk right down onto the screen with a very loud sound. And in fact, I do have a sound effect to go with that. It's called eliminated, and you get that impression. So that is what is going to be happening here. So we just need to code that animation. So when I receive intro, we're going to want to hide this. We don't need to see this at all. When I do receive eliminated, then we're going to go and land on top of the player. So we're just going to go to our player. Now I'm going to use a custom sprite. You guys remember we made custom sprites by going to My Block, custom block, sorry. We're going to go to My Block and make a block. Click this white button here. And that will give us a menu here that will allow us to set up some options. All we need in this case is to type the name in. You might already have this block, depending on which starter file you started with. But that gives us a define block here where we can say what happens when you're eliminated. And it has this execution block, which if you can't find, you can grab out of the side here. We're going to plop that right under here. One of the reasons I've used a custom block as well as making it nice and tidy is that there's two different things that are going to eliminate. There's going to be an elimination of your player, but the same script is going to be used on our AI players as well. So using this custom block here, I can recycle all of this code and make the same thing appear in two different places, which works quite nicely. So that saves us a little bit of trouble. Okay, so what happens when we eliminate here? We're going to go to the front layer. We're going to show. We're going to, but it's going to be invisible at first. We're setting our ghost effect to 100. We're going to make it really huge. We're going to blow it up to 300 in size, and then it's going to shrink very rapidly. Let's start that sound. So we're going to start sound eliminated. We're going to wait, I think. Let me just double check that. Yeah, a little bit of a wait for the sound to get going here. So as you heard, the sound kind of barrels in a little bit. It doesn't happen all at once. Oh. So at the beginning when it's going, we want nothing to happen. And then when the sound reaches a crescendo, that's when we want to start fading it in. So we're going to wait half a second. Then we're going to repeat 5 times. We're going to change our ghost effect by -20. So over the course of those 5 frames of animation, we're going to have our animation go from 100 down to 0, which will make it fully visible. Then we're going to, and while we're doing that, we're going to shrink. So we're way up at 300% size, and we're going to change our size by 40%. And anyone who's a whiz at math here will see that because we're doing that 5 times, that will make it it will subtract 200% from the size, which will bring our size down to 100%. So when this is all finished, That should be perfectly sized. All right, so we're ready to test this elimination script out. Let's max the game out here and give it a try. We'll skip the intro, run a little, and you can see that if we keep moving there, we get eliminated. We get switched to the game over screen. Now, you can hear that the creepy doll is still singing in the background. The game is continuing without us, and that is not quite right. The game's still continuing even right now as we're back to the intro screen. So we have one little bit of tidying up here, which is we have to stop all these scripts inside the doll to stop the game moving forward once we've died. So just one little addition here. Let's go back to the head again. So we're going to go when I receive that dead message. We're going to switch to red eyes, and that's going to show us that the doll is angry and we're in trouble. Then we're going to stop other scripts in this sprite. So that's just going to stop all of these various gameplay loops here and get everything silenced so that when we run our game over screen, we're not going to hear the doll singing anymore. We're just going to wait 3 seconds here and then switch back to the doll head again. And all this stuff will be restarted when we re-click the green flag or when we click on the screen. That'll trigger the intro again, and then we'll start the whole process over again. Okay, we'll give that one last test here.
Green light.
Let's run.
Red light.
All right, let's wait for these screens to subside here. We'll do one more round. And I'm just going to keep running here. There we go, eliminated. Okay, so I keep promising that we're almost done and then finding another feature that I forgot to implement. So right now our clock is not counting down, and we need to get that running. So we're going to use an event here called Start Clock to get that clock going, and we want to implement it right here. So we're back inside the doll sprite, and we're going to implement it right here. So when we receive that go signal, there's a stop other scripts in the sprite. We definitely want it to go after that. So right before we get into our forever loop here, let's do broadcast start clock. And then when I receive that, we're just going to start a simple 60-second timer going. So let's set a time variable to 60. That's a global variable. Instead of it all going down 60 times, though, we're going to add a little bit of intensity to the end of the time of the countdown, just to signal to our players that they'd better hustle if they want to get to the end. So we're going to go for the first 50 seconds. We're going to do a simple countdown. So we're going to change our time variable by -1, wait 1 second, and that will just get our timer running down in a nice fashion here. Just like that. All right, but for that last 10 seconds, we're going to do the same thing, time by -1 and wait 1 second, but we're also going to insert this little tick, tick, tick sound that I downloaded from freesound.org. And let's pop that in there, and you can see how when we play that with the timer, we get a little intensity here. Actually, I'm going to move that start sound to before the delay here. That works better. Okay, beautiful. Okay, so once that timer runs out, we're going to want to exit this loop here and end up down at the bottom, where we're going to play a little sound to tell us our time is up. There's a perfect little sound already in the Scratch library called Buzz Whir that I like to use for this kind of occasion. So we'll plunk that down there. Now we want to stop all the rest of the game action, so the progression of the game is all being controlled inside this head, so all we have to do is do a stop other scripts in the sprite, and then we will broadcast a game over message, which will get us back to our game over screen, and then the whole thing can start over again. So let's test that out right now. I'm just going to use the magic fast forward to skip through this here so that you can see what's happening. I'm also going to hide myself so that you can see the timer going down. So let's give that a try. Okay, the timer's about to hit 10 seconds here. Let's hear that ticking sound.
Green light.
And there we go, we've hit the game over event here, and we're ready to go again. Let me just click in here to start the game again. Alright, beautiful. That's all working quite nicely. Okay, we're pretty much ready to wrap up. There's a few little things that came up in our play testing, though, that are not quite right, and it's just because I haven't coded a few things yet. So let's clean that up right now. First of all, on the doll head, we need to, when I receive you win, to stop other scripts in this sprite. And the reason I'm adding this right now is because our countdown timer is running now, and it keeps running even after we win the game. So we do need to stop that countdown timer and stop the doll head spinning and all that other stuff when we do win the game. So that cleans that up. Also, we've got a stacking order issue. When I play tested this game through till victory, I found out that the doll head was popping in front of this you win. And the reason for that is, remember, when we win, we drop this down one layer in the stacking order to leave this room for this your rank first place here, which is under this sprite here called your rank. I haven't coded your rank yet, though, and so it's not moving to the front, which means the next closest to the front thing is the doll head, and that pops in front of you wins. So we do have to code this right now, otherwise we'll get a visual glitch, and I don't like those. Okay, so when I receive show rank, we're going to go to the front layer. We're going to switch to costume 0, which is at the very end here. It's just a costume that says your rank without any text on it. That's going to appear on the screen quickly as we fade in. So we're going to set the ghost effect to 100. We hid the object back here, so now we're going to show it. And we'll fade in using a change ghost effect by -10. Then we'll switch to costume 1, and we'll start flipping through these costumes one at a time. So if I'm in 10th place, it'll just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we'll just do it step by step until we finally get to 10th place or whatever. Okay, that's all good, and I think we're ready for one last run through. So I'm going to hide myself here, and we'll show the game one last time and just confirm that everything's working beautifully here. So let's go ahead and click the green flag.
Here is the first game. You will be playing red light, green light.
Green light.
All right, I'm approaching the finish line here, and I should make it this time through. There we go, across the finish line, you win. And my rank is first place. Excellent. And that is pretty much it. So we've got a pretty nicely functioning version of the game now. This actually works as a one-player red light, green light now. It's pretty much a freestanding game right now. All we have to do now is add our AI players. Now that's a little bit more of an involved process, so I thought I'd give it an episode all of its own. And we'll be getting to that next week. So stay tuned for that. In the meantime, please, if you're enjoying this content, my number of subscribers is still pretty low, so please subscribe. Leave me a like and a share as well. I just want lots of people watching these videos. I feel like I'm doing some good work here, and I'd like to have more people out there in the YouTube community watching what I do. So in the meantime, I will see you all next week. Thanks for joining me.